Welcome to the second part of the lecture on regression. I'm going to take you through an example of some data and use SPSS as I go along so that you understand how to use that. I just can't imagine that anybody would use those huge formulas for figuring out a regression line unless they had to. Although I'm going to encourage you to try it and see how it goes so that you understand where the different pieces are coming from. So we're going to go through this example. A group of researchers hypothesized that when adults exercise more, they're less likely to experience sadness. So they chose a random sample of adults and they gathered data on how much the subjects exercised. Then they administered an instrument that measures how much sadness each person experienced on a scale of 1 to 10, with 10 being the most sadness. So they put their data into SPSS, and you can see that the variables are labeled and that the scale that they used a scale measurement here so that SPSS knew what it was doing. After entering the data, the first thing that I do, I'm going to switch from this pretend researchers to saying I made up this data, okay? So first thing I'm going to do is I want to look at a scatter plot to see if the data is even linear. So you'll remember that I go up to graphs and use a chart builder, and I chose the scatter plot. I put hours of exercise on the x-axis because that's going to be my predictor, and I put sadness on the y-axis, which is the criterion. And when I look at my output, it does look like there's a linear organization of the data points. So now I'm ready to run my correlation on these two variables and see if they're correlated. To do this, you'll remember that I use analyze, correlate, and then bivariate. And when my the window pops open, I can move my variables over into the variables window. And if I want to get the mean and standard deviations, remember that I use the options button. And I click OK, and I get an output. According to the output, there is a correlation. They were able, and so there was a strong statistically significant negative correlation between exercise and amount of sadness. My R is negative 0.90, P less than 0.001. And as the amount of exercise increased, the level of sadness decreased. Notice that I put in my technical statement about the significant correlation, and then I explained what that meant. As the amount of exercise increased, the level of sadness decreased. That's a good pattern to always follow. I can also tell from my correlation that quite a bit of the variance in sadness levels in my made-up data was explained by the amount of exercise. So I can square my correlation, R squared equals 0.81. And that's a good statement for how to report that. 81% of the variance in sadness levels was explained by the amount of exercise. You can say was associated with the amount of exercise, was attributed to, depends on your research and your background and what your null hypothesis said. Now I'm going to do a regression. I want that predictor line so that, and an equation that describes this relationship between the two variables. So I go to Analyze, Regression, Linear, and I get the linear regression choices that pop open. So first of all, I put the hours of exercise, that's my predictor, so I'm going to put it on the independent, down in the independent variables box. And I'm going to put my sadness index in the dependent variables box. So I'm saying that exercise is the predictor, sadness is the criterion. And then for our purposes, all you need to do is click on OK, and you're going to get your output. So let's look at the information in this output. First of all, in the variables entered and removed box, the important thing here is that you can see that the dependent variable is sadness. It's always good to check that you got your variables in the right place. Let's look at the information in the model summary. This gives you another look at the correlation with a caution, but it also gives you your R squared. There's your correlation. There's your R squared, which is your variance. But look closely there. That correlation, there's something wrong. You'll remember that our correlation was negative. So this is not a good place in the output to get the correlation from. It's better to go down to the coefficients chart and find it under the standardized coefficients beta. And there you'll see that it's accurate with the negative signs. So make yourself a note of that it's much more, it's better to use it from the coefficients chart. So what can we report at this point? We can say, just as we did before, that there was a statistically significant. This is just another way to get to the same information. The model summary also gives me the standard error of estimate right there. Remember that I need to know the standard deviation so that I know how close my predictions of Y are going to be to the actual values. As a rule of thumb, when the standard error of estimate is small, your accuracy of prediction is good. So when you see a huge standard error of estimate, that means that those data points are all over compared to your regression line, and that wouldn't be good. We're not going to use the ANOVA information at this point in what we're learning about. So look next at the coefficients table. And this is the one that's really, really important for regression. The coefficients table is going to have what you need to make your regression line. First of all, it clearly reminds us that the dependent variable is sadness. Always good to check. Now, let's look at the regression equation, and we're going to look for the regression coefficient, which is the slope, and the regression constant, which is the Y-intercept. So here's the constant. It's clearly labeled, and so as you can imagine, the other one is your slope. So the constant is labeled, and there's your slope. So now we have the pieces we need to make the regression equation. All we do is replace we take the information from the chart and we put it into our equation. What can we say about the regression at this point? We can say that the hours of exercise significantly predicted sadness scores, and then you put the slope in, B equals negative 1.26, and P point is less than 0.001. We don't generally put the Y-intercept into a statement. So now this is the equation of a line that I can use for predicting how much sadness will be for each value of X. So if I want to predict how much sadness will be felt when a person gets 7 hours of exercise, I can do that. I simply replace the X with 7. Notice the little hat over the Y, and I end up with 1.98. That's the predicted score that a person is going to have on the that's the predicted score on sadness that someone will have when they get 7 hours of exercise a week. Now the Y-intercept is really important for actually drawing the regression line. You know from our equation that the line is going to cross the y-axis at 0.8 or 10.8. Now, so you've got one dot. Now to draw a line, you need 2 data points. Pick any value you want to for x. I'm going to pick 6. And I'm going to put 6 into my value for x. And then I can predict that my score is going at 6 hours of exercise is going to be 3.24. So I'm going to put my dot right there above the 3. And then I just simply have to connect those dots. So one of my data points is going to be at an x value of 6 and a y value of 3.24. And I connect the dots. Now, it's fine to draw this by hand, but I want to probably get the line on my scatter plot in SPSS. So in my output, when I put the mouse over the graph, I get a message that I can double click it to activate that. So I double click that, and up pops a chart editor. And what I'm looking for is the icon that says Add Fit Line at Total, and it's this one right here. Let me show you that again, right there. Right there. And it'll give me some options. You want the linear line. You don't want the mean of y or a quadratic or anything like that. You want the linear line. And so stay with that default. And you can just close this because you're not changing anything. And you get, when you close your chart editor, you're going to get a graph that has not only the line drawn in it, but you're also going to get your equation there. So that's all there is to coming up with regression in SPSS.